Okay, so today we're going to be doing a review of converting units, perimeter, and area. So this is stuff that you guys have all done before in previous years. So first, just going to talk quickly about converting metric units. So these are sort of units like kilometers, meters, centimeters, and millimeters. Now, metric means that it is in powers of 10. So what you need to think about when you're converting between metric units is thinking about multiplying or dividing by powers of 10. So let's do the easy one. So if we're going from kilometers to meters, you'll want to multiply by 1000. And if you are going from, say, meters to centimeters, you're going to be multiplying by 100, and centimeters to millimeters, you're going to be multiplying by 10. Now, similarly, when we're going from meters to kilometers, going this way, we're going to divide by 1000. Going from centimeters to meters, we're going to divide by 100. And going from millimeters to centimeters, we're going to divide by 10. So the way that kind of looks is that when we've got I don't know, 250 meters into kilometers, and we'll go, okay, so therefore that means it's 250 meters divided by 1000. So move our decimal place 3 spots, so that means we're going to have 0.250 kilometers. Okay, so essentially, if we're going to go from to a smaller unit, we need to multiply by different powers of 10. But if we're going from a smaller to a bigger, we want to divide by powers of 10. Okay, this is all sort of stuff you've seen before. Not a lot of this should be new. So that's just a quick little review of that. Okay, perimeter. So the perimeter of any shape is simply the sum of its sides. Now, there's not really a formula for different shapes for their perimeters, so I'm just going to have a look at a couple just to show you that really you just add together the sides. So here's example number 1. We've got a square. You can quite clearly see it's a square because I've got the little marks here that show you that each side is the same. So that means that each side here is 5 centimeters. So therefore, for this one, we've got the perimeter equals the sum of the sides. So you can write it like that, and there's a couple of different ways, but this will be fine. So the sides here will be 5 plus 5 plus 5 plus 5, or 4 times 5, which is equal to 20 centimeters. Okay, now units are really important. You're going to drop half marks on exams, and later on in life when you're looking at different sciences and stuff, units and what units you're in, really important. So please make sure that you're attentive to what your units are and what they're supposed to be. Okay, right, so here's a rectangle, and so when we're looking at the perimeter for this one, same sort of thing happens. For a perimeter of a rectangle, perimeter equals the sum of the sides. So now I've got double dashes here which says that both these sides are 10 centimeters and both these sides here are 4 centimeters. Okay, so an important thing with geometry is, even though this sort of looks like it could be closer to 3 centimeters, this length here, don't trust your instinct on what things are supposed to be. Look at it and see what sort of geometric proofs they've been given so that you can know what length things are. Okay, so some of the sides, so we have 4 plus 4 plus 10 plus 10, 8 plus 20 equals 28 centimeters. Okay, so again, make sure your units are in there. So here we have a triangle, same deal. Look for where you've got your different sides, and we're right to go. This one's pretty easy. Perimeter is the sum of the sides, which is 10 plus 6 plus 3. Now they're all in meters. And so we have 16 plus 3 is 19 centimeters. Oh, no, this one here is meters, so let's just fix that up. So we have 19 meters. Okay. Right, this one here, I haven't even got any units, so it doesn't really matter. Let's just make them all meters for now. Meters, meters, meters. So, perimeter of this crazy shape here is sum of the sides. So there's not going to be formulas for these ones. You just have to remember that you add up the sides. So we have 3. Let's start here. Go anti-clockwise. 3 plus 7 plus 9 plus 4 plus 3. And now we've got this sort of little bit here that there's not an amount explicitly stated for it. But there's actually no real indicator. Well done. So I'm going to make it straight off the bat. That is 4. Plus 4. Nice work, Mr. Brady. So 3 and 7 is 10 plus 13 plus 7. So we have 20. 30. Wow. 30 meters. Cool. This is working out very well. Okay, now onto something that hopefully should be a little easier. Area. Now, when you guys have done this before, but I just want to take a little bit of time out here just to sort of talk a little bit about things. So, before you've had, like, if you have a point, that's 0 dimensions, okay? So, if we go on the point, we can't go anywhere 0 dimensions, but we can add sort of like another point, join them together, and give ourselves a line, okay? Now we've got 1 dimension, okay? So right now we can go back and forward all over this thing. So what happens if we project this line up? Okay, so we could go along this line, you know, some amount of units, okay? So let's say it's just 10 units, and then we can go up. We're going to project this whole line up across here now. So now we're looking at, we're going to project it up. We've projected up maybe 4 units, okay? And now we have what's called an array. Okay, 10 units going this way, 4 units going this way, and now we've created an array, this space here, and what we call that as well is, we've also called it things like an area, okay? So this is how we do areas, is that we have a certain amount of units multiplied by another amount of units creates an array, which we use as an area when we're doing geometry and spatial stuff, okay? So, we look at area of a square. This is the easiest. Just going to roll through these quite quickly because, again, it's all, should all be revision for you guys. So, area of a square, so we have area equals side times a side, okay? Or you could have it as side squared, okay? So we have 5, so all these lines here telling me that they're all 5, so we have 5 times 5 equals 25. Now units, we have technically 5 meters times 5 meters. So if we have meters times meters, that's equal to meters squared. That's why we get 25 meters squared as the units for area. So there's squared units. Okay, area of a rectangle. Again, we need to look for, so I guess a key idea for area is that there are 2 lengths being multiplied. Okay, so if we look here, we've got area, so area of a rectangle, most of you will know that as the length times the width of the rectangle, and so that's can be L times W is fine. So we have 12 times 3, which is equal to 36 meters squared. Now this unit here, we can say that as meters squared or square meters. Okay, not meters 2 or anything crazy like that. Alright, area of a triangle. Here's the one that's slightly a little bit different. Now, you might have seen things like area of triangle, so questions can kind of come up like this, and you know, you're given a what's called the perpendicular height. Okay, so here's your base length, and this thing here is your perpendicular height. Okay, so that's your perpendicular height there, and here's your base. Now, essentially this perpendicular height, wherever you choose the base, whichever side your base is, your perpendicular height has to go from that base up to the top. So here I've drawn a triangle on a bit of a weird angle. So I've gone with the base being this one here, so the perpendicular height has to be measured from in line with the base here. See, got in line with that, extends all the way up to the top here. Okay, so that your perpendicular height always has to be at a right angle to the base. Okay, so key idea. So perpendicular height let me sort that out. Perpendicular height is always at a right angle to the base length. Okay, or slash side. Okay, so if we choose this one here, so the area of our triangle, this might be something you've remembered. Oh, I like to do this, by the way, A with the subscript. So really for the square and rectangle, I should have done A subscript square, A subscript rectangle. That's sort of the way I want you guys to show me that you know you're constructing the area of a triangle now. So it's going to be half base times height. Okay, so this is our base length, the part's on the bottom. And so that's going to be a half of 4 times 7, okay, which is equal to a half of 28, which is 14 centimeters squared. Okay, now see this half base times height, that's sort of comes from the idea that a triangle is half of a rectangle. So, you know, if you've got, see here could be our triangle here that I'm sort of colouring in. You can see that the area of this thing is half of the area of a rectangle, which would be, you know, sort of a length by a width. Okay, so that's how we get the triangles being half of a rectangle's area. Okay, right, it's a quick video. Essentially it's just recap stuff. We'll have a chance to practice this in class and really move on quite quickly into some different types of areas on unusual quadrilaterals and circles. So enjoy that. Thank you.